Now, having introduced distributed shared memory, I want to give sort of a bird's eye view of the history of shared memory systems over the last 20 plus years. My intent is not to go into the details of every one of these different systems because that can take forever, but it is just to give you sort of the space occupied by all the efforts that have gone on in building shared memory systems, both in hardware and in software. I encourage you to surf the web to identify papers and literature on these different systems that have been built over time, just to get a perspective on how far we've come in the space of building shared memory systems. A few thoughts. On the software side, software DSM was very first thought of in the mid-80s. The Ivy system that was built at Yale University by Kai Lee, and the Clouds operating system that was built at Georgia Tech, and there are similar systems built at UPenn. This, I would say, is the beginning of software distributed shared memory. Later on, in the early 90s, systems like Munin and Treadmarks were built. I would call them perhaps a second generation of distributed shared memory systems. And in the later half of the 90s, there were systems like Blizzard, Shasta, Kashmir, and Beehive that took some of the ideas from the early 90s even further. And in parallel with the software DSM, I would say there was also a completely different track that was being pursued, and that is providing structured objects in a cluster for programming. And systems such as Linda and Orca were done in the early 90s. Stampede at Georgia Tech was done in concert with Digital Equipment Corporation in the mid-90s and continued on later on into Stampede RT and PTS. And in fact, in a later lesson, we'll talk about persistent temporal streams. And this particular axis of development of structured distributed shared memory is attractive because it gives a higher level abstraction than just memory to computations that needs to be built on a cluster. Early hardware shared memory systems such as BB and Butterfly and sequence symmetry appeared in the market in the mid-80s, and the synchronization paper that we saw earlier by Melacramy and Scott used BB and Butterfly and sequence symmetry as the experimental platform for the evaluation of the different synchronization algorithms. KSR1 was another shared memory machine that was built in the early 90s. Alewife was a research prototype that was built at MIT. Dash was a research prototype that was built at Stanford, and both of them looked at how to scale up beyond an SMP and build a truly distributed shared memory machine. And commercial versions of that started appearing. SGI, Silicon Graphics, built SGI Origin 2000 as a scalable version of a distributed shared memory machine. SGI Altix later on took it even further. Thousands of processors exist in SGI Altix as a large-scale shared memory machine. IBM Blue Gene is another example. And today, if you look at what is going on in the space of high-performance computing, it is clusters of SMPs which have become the workhorses in data centers. I very much want you to reflect on the progress that has been made in shared memory systems and invite you to look at some of the details of machines that have been built in the past, either in the hardware or in software, so that you can learn the progress that has been made.